I'm going to have to get it in parts as slow as it's saving anyhow. Okay, so looking at limits as far as if you're going to try to do them by the equation, I'm repeating this, you guys just heard this. If they give you the function and you want to approach a number, I drew the graph of this function, and we saw that as we approached 2 on the left and the right, that the y-coordinate was headed toward 5. And Abby just pointed out then that it's the same thing as if you subbed 2 into the equation, 2 squared plus 1 would equal 5. So that's the first step of doing a limit. The first step. So on this limit I have written down here, if I want to know the limit as x approaches -4, what would you all think I should try to do? Put -4 in. So we would have -4 squared minus 3 times -4 over the square root of -4 plus 8. Okay, algebra, what do we got? There we go. 16 plus 12 over square root of 4, which is 2. 28 divided by 2 is 14. And ta-da! As long as you get an answer, you have solved the limit.
And you keep off on that.
As long as you get a legitimate numerical value, you're done. You found it.
But
So, when do you not get a nice value? That's the question. So, let's look at another one here. Suppose I gave you x squared plus 4x minus 21 all over x squared minus 3x. And we're doing the limit as x approaches 3. So, what's the first step?
plug it in.
Plug it in. Plug it in, plug it in. Commercial. Okay, so if you put 3 in there, you got 9 plus 12 minus 21. You got 9 minus 9, don't you? So you have 0 over 0. What's 0 divided by 0? Well, it's undefined if it's a number over 0. You have 7 over 0 or 15 over 0. That's undefined. 0 over 0 is actually something we can't determine what it is. And so it's called an indeterminate form. New vocabulary. You can't determine what 0 over 0 is. We won't get to it this year, but in full-blown calculus, there's other indeterminate forms. Infinity divided by infinity. What's that? Which infinity is bigger? Are they the same? What do you get when you do infinity divided by infinity? So there are several different indeterminate forms. If you get, in this case, we're only going to get 0 over 0. If you get that, that means you have to try some fancy algebra on it to see if you can get it into something that's more useful. So, what is some algebra we could try on this problem? Just looking at this function, what is something you typically can do with fractions? You can try to cancel, but what do you have to do before you can try to cancel? Factor, yeah. So we're going to try to factor this thing. And if we do that, what, plus 7 minus 3, that's no big deal. Can you factor the bottom one? Let's all not jump on it at once. It's taking 50 times longer. Help.
Yes, no.
What do you do the bottom one? Pull an X out. So yes, factoring is one very solid method for trying to see if you can simplify this out of your indeterminate form. And hey, wow, look. Yeah. So then, once you get it, something to cancel, now try to put the number back in again. In this case, try to put 3 back in. What do we get? 10 over 3. And ta-da! There really was an answer. You just had to do some algebra to it to get rid of what was causing it to be indeterminate.
That's it?
That's it. Now, I need to threaten you. Okay. In calculus, notation is super important. writing down the symbols so you know what you're talking about. These symbols need to mean something to you. When you write lim x arrow -4, that you need to be going, oh, that means the limit as x approaches the x coordinate -4. You need to make those make sense. You must write limits as long as there are variables in the problem. Once you actually successfully get it to a number, then of course you have found the limit and you stop writing limit. But you will write limit as long as there are variables in there. I will take a half point for every LIM you leave off. Right, limit. Okay, this is my way or the highway deal. Notation is critical in calculus. You have to learn to notate correctly. Absolutely live and die by it. All right, so let us make a little set of steps here for what we just mastered. Limits. When you're first working in them, the first thing you should do is sub the number in. Okay. If you get 0 over 0, and that's all for this year that you're going to get is 0, 0, then what do you try if you get 0, 0? Right now, yes. One thing you can try is factoring. There's going to be another one. So we're going to try another little short problem here and see if we all remember our factoring rules at the same time. We have x cubed plus 125 over x squared minus 25. Okay, and we're approaching -5. My arrow is really bad there, but the limit as x approaches -5, that lovely fraction expression. What do we do first? Sub the number in. Okay, so if I sub in -5 and cube it, that's a -125 plus a positive 125. And on the bottom, it would become 25 minus 25. Oh no, it's 0 over 0. And that's called what?
Indeterminate.
Indeterminate. That's an indeterminate form. So we go, ha, have to pull some algebra on it. Are these factorable?
Yes.
Yes, these are factorable. Okay, you remember how to factor perfect cubes?
5.
Exactly. It's the 2-term times 3 terms one. Okay, how did you know what went in the 2-term binomial? You uncubed them.
Hey, right limit.
Thank you. I was waiting for somebody to know. Very good. Jumped on that. Yeah. Yes, I need my limit out front because it still has x's in it. So, yes, Bailey's right. It's x plus 5. Now, how did we do get the trinomial? Yeah. 25 is at the end. Plus 25 is on the end. How do you get the middle term?
Multiply the 1, 2.
Yes, you multiply the 2 up here in the front. The x and the 5. And you change the sign. So it's just minus 5x. Okay, now, the bottom one, I would hope we can factor. There you go. X plus 5 and x minus 5.
Whoa.
It crosses off. So goodbye, x plus 5. So then, what do you try once you get it to cancel? We try putting the number back in. And since I'm putting numbers in, I don't have to write limits. So if I square -25, I'm going to get a positive 25 plus a positive 25 plus a positive 25. That's pretty cool. And on the bottom, -5 minus 5.
-5 over 2.
Wouldn't that be 75 over -10, and then you're reducing it?
Whoa. I did not get that. Oops. No, I did wrong. No.
And I would reduce by 5. So it's going to come down to 15 over 2, or 7.5. got an answer. Ta-da!
Well, we're done, right?
Wrong! Whoa, wrong. Ah! I haven't got to the other one yet, because we have to do the other one. Why isn't the other one on there? Okay, oh well. Okay, I guess we're switching colors. One more of this kind, and no, we aren't done, because I haven't ever played catch up on the snow days yet. So it's in this section we're catching up on the snow days. So we're learning a little bit of stuff that pertains to the next section as well. Okay, this one is more of a sneaky trick deal. If you try to sub the number in, is it going to work? The square root of 64, that's going to be 8 minus 8. That's 0. And 64 minus 64 is 0, so we're indeterminate. Are you going to factor that? No. You're not going to factor that. So, this is where something that you learned back when we were learning how to work with it and simplify square root things suddenly becomes useful. Do you remember what you did back when you had like fractions and you had 2 plus square root of 3 on the bottom of a fraction and you didn't want the square root on the bottom of the fraction? You rationalized it by multiplying by what? Yes, we multiplied by the conjugate. Why did we like conjugates? Your middle terms cancel out, and when you just do your first and your last, it comes out to nice whole numbers. So that was good for rationalizing. It's extra good here. If you see that you have a square root plus or minus a number, you can use a conjugate to help you solve it. And it does not have to be in the denominator. In this case, could I use a conjugate? In the numerator, because the numerator's got square root of x minus 8. So I actually am going to do a conjugate on the numerator. But it's still, algebraically, it's going to help me either way I go. So what is the conjugate of this one?
42.5.
Okay, it would be square root of x plus 8. And of course, so I have to multiply it times the bottom too. So now, when I do that, because on top they're conjugates of each other, I know I only have to multiply which one? First and last. So what do you get when you take square root of x times itself? X. And 8 times 8 is going to be a negative 64. Oh, look, it's an x minus 64. Have we seen that somewhere before? It's on the bottom. So you don't want to FOIL the bottom together, which it would be totally ugly if you did, because when you do the conjugate, you should end up with something that will cancel then. So leave that bottom unfoiled, because then you can go, sayonara, dude, x minus 64 is out of there. Okay, so then what should you do? Then you should, you got a 1 left on top. After you've canceled, you usually try to do what? Put your number back in. So what you're going to get when you do square root of 64 plus 8? It's going to be 8 plus 8, and we got 1/16. Answer. So conjugates can get you out of the hole sometimes. If it's a square root plus something or a square root minus something, conjugates can help. So that's the other thing that's going on our list back here. The other thing you can try is a conjugate. So that list is important. I'm sure there's something about it on your journal. Imagine that. Oh, sorry, did I need to leave it there?
High school conjugate.
Keep your hands to yourself. Conjugate, how do you spell conjugate? C-O-N-J-U-G. A-to-A-T-E, oh, I just wrote it right there, duh.
Oh.
Conjugate. So, something that I don't always appreciate, oops, save.